This is a solar collector project I started in 1980. This particular collector I made in probably 90 or so. Might have been a little before that. The whole purpose of it is to reflect sunlight off of that mirror onto this spot. And this is some pipes. And so they will heat and boil the water, turn a steam turbine motor, which will in turn power electric generator. So that's how about probably 90% or more of all of our energy, including nuclear, gets produced in our world today, except for hydro. That's a different kind of a turbine. Don't even look like a steam turbine really, because it's made for water. Anyway, this involves the mirror, and if you're talking about a 20-foot or a 60-foot mirror, you're looking at a lot more complexity than this. Is about 2 feet in diameter. Same with the tower, what you're looking at with the tower. It would be similar, you know, some kind of pipes holding up the receiver, which has got the steam tubes in it. This is the whole tracking mechanism. This particular type that I developed myself sits right on top of a U-joint. This is a U-joint off of a tool, automotive tool. And then for larger ones you use a U-joint off of a car. I worked on that for a long time. Then it's got a tracking system. At the moment I would use a bike chain to grip it real good. I was using rollers and stuff, but they don't grip it too good. I finally figured out a way to do the rope drive, which I think will be a lot less expensive and easier to make, and potentially can avoid almost all the electronics to keep that bad boy up there pointed right at the sun. Because you can see this is not as complicated as a telescope, but it's very similar. It's got the mirror, it's got the receiver, which would be the camera usually on the big telescopes we're using these days, and it's got the tracking system. So it's essentially a large Newtonian telescope. Well, not really Newtonian, because Newton invented the darn thing, so let's give him some credit. But the reflecting mirrors have been around for a long time, including stories of Archimedes getting the Greek soldiers to polish their shields, making mirrors. And they probably could have set fires to the sails and scared the living daylights out of the superstitious sailors who never seen anything like that, reflecting 300-400 suns, because you can burn paper even with something like this. And this has only got, I think, 50 mirrors at the most, so that would certainly work. These things are used for many different things. With multiple reflections, you can achieve 75, or has been achieved, 75,000 degrees Fahrenheit, which is hotter than the surface of the sun. With a single reflection on a quality mirror, they're typically getting 4,500 degrees Fahrenheit, which leaves them testing jet aircraft parts, because of the extreme high temperature, the lack of electromagnetic or fossil fuel pollution, and the fact you can cycle them quickly and it's not a problem. Move it right into the heat and right out of the heat, do it all day long, and that's what you want us to do, the cycling. So that's what Omnium G in Pasadena, California was doing in 1982 when I stopped down to visit them. It was kind of fun seeing how they built their stuff. Anyway, I've been at it a long time. I got some great ideas, including orbital power stations, and you would make the glass right on the moon. You try to get some moon dust and melt it, make foamy glass, and then casting that sort of thing in space should be real interesting and fun. Use a smaller mirror to make a larger mirror with extremely high temperatures. Then you could send quality products, building products, foamy glass products back to Earth. You could send energy back to Earth pretty easy. Right on Earth with a terrestrial based thing, you could use different kinds of high temperature chemical conversion systems to obtain, for example, a dry powder, which could be mixed with perhaps water and become a gas that could be burned in your car, so you wouldn't need fossil fuels anymore. That'd be kind of fun. And eliminate pollution. And that is why I started this project. Part of it was to I was really mad at the oil companies for pulling that farce, absolute farce, of a gas crisis on us. And then I also thought I'd maybe save some lives because of people who were dying from respiratory illness caused by smog. And there's a lot of people with asthma and stuff and suffering, and has been over the years, and that's a shame. That's a horrible shame. I think if we collectively wanted to do something, we would, but maybe most people don't. Most people don't know about it, and the extremely wealthy people who could do something about it, maybe they're got their hands tied too. There's all kinds of things that can tie your hands down, not just greed for money. So the reason I want to do this was I went to India in 1979, and when I got back, I thought I had talked to an architect there, and he says they were, you know, working on reforestation of the country, because 2,000 years ago it was covered with trees, and now it's a desert. People cut down the trees and they just don't grow back, just like in California, lots of other places in the world. And the problem they were having was watering the trees for 5 years while the roots hit groundwater, very expensive. And so we agreed that if they had a cheap solar water pump, then they could achieve their end a lot easier. There is a lot of work on this kind of collector done in India, and that's great. I'm not sure if anyone has exploited the NASA water pump that was made a pure vapor system using a pressure cooker. So you eliminate the need for the motor and all that expense. Probably going to lose some efficiency, but you could certainly improve the efficiency. And anyway, that's one of the things you could use as far as a remote agricultural water pump. So there's an awful lot of things you could do with this thing. I've gone through a few of them, and if you can think of more, that'd be great. But for the average house, you could certainly be looking at putting in hot water and electricity with the same unit, and that would be a benefit. You could put it on a roof, but it'd be better in a backyard. I don't know if it would look too good on most roofs, unless you had a big flat roof like in a city. Then it would make a good shade tree if you put it up a little higher. As long as the roof could sustain the wind loads that would be delivered to the collector. There's a big 20-foot or whatever collector is going to get a big old wind load when the wind hits it. Anyway, you got 7 minutes and 42. If you've lasted through this video this long, well, thank you. And please leave some comments and like the video and do all that good stuff. Maybe go and loan me some money or donate some money to this project. I've got a couple, going to start up a couple of Kickstarters type things, and I hope you guys are doing good. So talk to you again. Bye bye.